Hello everybody, welcome to Plain Mundane Show. Oh, did you see that jet ski? Ooh, there goes another one. Those two jet skis are only about a half a mile away. 3/4 of a mile. But where you're looking at off in the distance, that bridge, that boat over there, that's about 3 to 4 miles away. I can't even see that boat. Alright, see there. See that boat over there? Going into the marina over there, that's the Kemah bridge if you see the cars going above in the treetop area. That's 4 miles away from where I'm at. Of course, I'm on the Nassau Bay, Clear Lake, Seabrook side, and I'm sitting behind the NASA Hilton. And I'm looking out across the bay to Kemah, which is about 3.8 miles, I think, 4 miles from here. And I'm laying on a rock just above the water surface, and I think that might be moving because it's debris teetering. I'm going to touch it to focus it. Hold on. Okay. Now that you're looking at, let's say it's about 4 miles away. That boat right there, let's see if I can see it. I can see that with my eye. That's about 2/3 of the way to that bridge, that boat. Of course, if you measure circumference of the Earth and the curvature drop at 4 miles, where those cars are going across that bridge, that should be about an 8 to 10 foot drop. Right now in Seabrook area, it is almost noon here in June, first half of June. You could say that some of the blur at the line, as you can see that boat going, the further it gets out, we'll see it disappear from the bottom up. But here's a secret trick I learned, guys. The water in front of us. I'm going to back up here to show you this pier. Okay, do you see the pier? I'm going to back up all the way to where I'm at. I'm right on the water's edge at the pier behind the Hilton NASA. On NASA Road 1 between Clear Lake and Seabrook. This might actually be part of Pasadena. There's like 5 or 6 townships that come together all on this little bay. It's about 4 miles across. So now look, what I wanted to show you is this pier that I'm next to. That goes out what? It's going out about 100 yards from where I'm lying. And fish jump here all the time. I come here to watch the fish jump. And when the fish jump, they actually jump above that blurry line that's on the water horizon. And that's where your focus of your vanishing point of perspective shifts in what I would call gradient pixelation. You know, you go from your close-up distance, which is the water you're looking at. Like right now, the water we're looking at that's going all the way up to that distant horizon line is really just the water around the pier's end. You know, it's only 100 to 200 yards in front of you, maybe up to 400 yards. After that, it shifts into a long distance range perspective, and it blurs, and that causes that blurry line you see where everything disappears from the bottom up. It's because it sinks into the gradient shift of the shift in your focus density gradient. Look at it as a gradient pixelation fading gradient, but it actually has to do with the your rods and cones and your retina and the way you perceive things with your eyeballs. Now watch, I'm going to zoom back out. Forgive the shake. Okay, now just focus it. All right, I stopped touching it. Okay, good, we have a boat there. That little thing should be gone at 8 to 10 feet. You should only be able to see about half of that jet ski. Of course, like I said, those cars on that bridge are about 4 miles away. That boat, looking with the naked eye, that's about halfway between us. I can see that boat. But here's what I was talking about. Look at the water in front of here. Now, there's a lot of vehicles moving out here. That makes it cool to demonstrate. Now that jet ski, I can see that one. That's only about 1.25 miles right in front of me. Within 1.5 miles, right in the middle over here, coming towards me. But the cars going across the bridge are like 3.8 miles away. But what I was telling you, all the water between me laying on this rock up to the water line where the blurry line starts, that is really just, I would say, 200 to 250 yards of water in front of me. All the rest is the blurry line. All the rest of the distance is squashed into that blurry line where the boats disappear from the bottom up. They get sucked into the gradient shift of the change in your perspective. It's like a distance focusing algorithm that's different than your close-up. And I figured this out because I saw fish jumping. And if you focus on the cupping shape of the water and the chop of the water, it's close up. It's not that far away. You can focus on it. Can you see that? There's another boat. See, now that one's kind of blurry from the bottom up. It's far enough away where I cannot see it with my naked eye, barely. I think I'm looking at another boat. But yeah, that blurry line right at the water line in the middle of your screen, you know how they say the horizon always rises up to your eye level. There's always that hairline that's all blurry where the bottom of the boats disappear into. And that is where your retinas with your rods and cones are shifting in gradient perspective range of focus. And all of the water that you're seeing right now, all the way up to that boat out there, that boat's about 2.5 miles away. But all the water you're seeing shining in front of it is just 200 yards away. All the way up to that blurry line. Because I watched fish jump out of it, and the fish were jumping around the pier here, and I knew they were close to me. But they were jumping out of and over that blurry line up over the horizon. So it gave me a way to perceive which water at what distance I was looking at. And the fish jumping out of the water at the end of the pier were a marker showing me that, wow. So all that water that rises up to our eye level is just a few hundred yards in front of us. A couple of 100 yards in front of us. To the blurry line. I don't know if there's a name for that. But people think that's that blurry line is from atmospheric conditions and steam, and it's hot, and it's almost noon, and that causes light to bend and refraction to be able to see over a ball. And so, but at the same time, it's matter with density, and you can't see through it, so the bottom of the boat disappears. I don't believe that's true, folks. If you're just doing a lot of observance, I come here a lot, and I just don't see that. Sorry. It's a shift in your gradient of your perspective focusing power over distance. It's like an inverse square that just shifts off into infinity in that blur. It's like a bifocal line, you know? That's the good allegory. It'd be like a bifocal line if you're wearing bifocals. That's the bifocal point, is the line that rises up to your eye level. You may hear a pretty fast boat out here if you can hear that. That's what it's like. You're looking at all that stuff happening 4 miles away, and it, like, you know, you can see what they're wearing and their feet on their jet skis and stuff in the bottom of the hulls of the boats. Let's go back out. Forgive me for touching. Here we go. Want to zoom? 1, 2, 3. Electronic zoom. We need to see fish jumping so that you can see how they go over the horizon. Let's have some fish jump, please. Okay, let's back up. All right, folks, that was fun. I come out here a lot and I do different filming and I edit this stuff, and I'll upload it and show it to you because I think it's fun. I come out here and test distances and formulas and curvature formulas, and it's a lot of fun. Please hit like, subscribe, and ring the bell, and of course come back and see us. Bye.